welcome friends to this NPTEL module on handling healthcare survey data. We are on the third week. Myself Dr. Pratap Mohanty attached with IIT Roorkee in the Department of Humanities and Social Sciences. This lecture we have targeted to make you clarified with certain important directions in research, especially writing research papers, how reviewers is demanding certain contents of your analysis, such as weights and representative sampling. In any analysis you do, the reviewers are expecting or the editors are expecting that your results must be representative enough. Your results from the sampling or from the data must be telling stories to a larger segment, so that any sort of policy implementation could be made based on your paper, based on your results. But representative sampling, as we have already read earlier, that it requires more sample size. It requires sample size has to be reasonably higher, larger. Without that, in a small sample case, it is very difficult to represent the population. So, there are certain techniques to represent our population through weights. But weights, why should I give weights? Why should I give overemphasis on certain segment? Like all we know that in India, the structure of India is highly divided. There are huge hierarchies in the Indian context, so far as development is concerned, and certain sections are having huge inequalities, and there are resources not well distributed. That is the reason why when your data itself is not normal, it is skewed. In all our statistical techniques, in our approaches, we know that the data has to be presented in a shape like normal distribution. Then only we can expect and estimate number of inferences out of it. But if your data is skewed, we know that average technique, averaging the outcome is not the right indicator. There are certain other indicators. So, just based on a data like income, for example, in the society is very skewed. Okay, like only 10% of the population holding 90% of the income. Okay, in that case, if you are simply taking per capita income, I think it is going to be misleading. Okay. So in that way, when you are estimating any average income, it should be representing people in a right way. The distribution has to be first made normal. Okay, and then that approach we are dealing with in our next lecture, how to normalize it. But at this moment, I am just trying to say that certain weights are required, certain valuation are required to a particular variable that would actually lead your interpretation in a better way and an acceptability of your paper to a larger segment. So, this is what all about the background regarding weight. Now, let us understand the introduction to it. I have with my team in this particular segment, they have been consistently helping out. They are Mr. Milind and Mr. Kamal, and they are part of the Humanities and Social Science department. They have been working with this NPTEL project. So, Milind and Kamal has developed all those important connections in the PPT, and you will learn the know-hows very clearly if you practice in a very systematic manner. So, let us go ahead and understand. So, first of all, while conducting a survey, having a representative sampling of the population in any kind of study is of utmost importance, and the representative sample has some characteristics in the same proportion as the population it is drawn from. So, the sample should also narrate the story of your population. Okay. In practice, we are prone to oversample some kind of people, and undersample others, which leads to sample bias. You might have heard about sampling bias. Even in we knowingly create certain possible bias in our model. Some of the variables are dropped, some of the observations are dropped. There are many ways where sample bias are created. So, we have certain techniques to minimize the bias. Okay, at this moment I am not exactly hitting the solutions for correcting the sampling bias all totally, but some of the approaches we are addressing. So, oversampling means oversampling in region with small populations ensures that they have a large enough sample to be representative, whereas in the other case like undersampling with larger population sizes in order for the survey to be very cost effective, we take a very specific sampling. So, that has actually undermined the sampling requirement, and that is why we are saying undersampling. Now, weighting is in fact a statistical technique for removing bias from a survey sample, whether it is oversampled or it is undersampled. In both the case there are possibility of biases. So, the weighting method helps in correcting those things. This ensures more representativeness of the target population. Weights are used to actually restore the representativeness of the sample, so that it looks like the actual population. Now, I am coming to the exact definition of those technical terms we are using. So, it is taken from the Demographic and Health Survey DHS, where IFH Indian National Family Health Survey is attributed to. So, the technical definition as per the DHS is that a representative factor applied to each case in tabulations, which is in relations with the overall probability of selection and interview for each case in a sample, either due to design or happenstance. Okay, so, that these are technical definitions. In practical definitions, and this is going to be more understood, is that a number that is multiplied by each case, maybe for women, maybe for children, household, couple, to weight up or weight down that observation if under or over sampling is applied. So, weight off is possible, or weight down is possible if we apply the exact sampling procedure. So, let us understand that further. If a woman in a survey has a normalized weight of 1.2, she represents 1.2 women in the total survey population. So, it is not 1. Usually each person used to carry 1 without any weight to it. If we carry with normalized weight, its coefficient or the weight value matters. So, it represents 1.2 times of the total survey. It is 2 size of its total population, total survey population. If a household in a survey has a normalized weight of 0.8, it represents 0.8 households in the total survey population. So, accordingly the weights are interpreted. So, let us understand a weight is assigned to reflect the data items relative importance based on objective of the data collection. So, its relative importance in the total data collection is carried in the total population. Take into account the characteristics of sampling design. Okay. So, this also emphasizes or give proper weight, proper emphasis to the sampling design which was initially framed. This also helps in reducing biases arising from non-response when the characteristics of the respondents differ from those not responding. So, reduction of biases, it gives relative importance to some of the sections, then it helps in proper designing as per the expectations, and this also helps in correcting identifiable deviations from the population characteristics. If there are some deviation from the population, since it is not representing correctly, your weight may lead to representing this in a better way. So, there are different types of weights serves various purposes and have varying effects on data analysis. Should we use weight or not? That is an obvious question arises in any study. Often we are confused, should I go for it or not? Let us try some heat and trial process. Let us go for heat and trial process. If it is suitable to my work, then I will go for it, else I will not consider it. In fact, that is not the right way. Usually researchers do in that manner, but some guidance we are giving it. There might be many other ways for understanding, but let us go by this approach. Weights may be ineffective for certain types of analysis, such as estimating associations or regressions, and so on. On regression, we have certain expert views, literature reviews. I am just going to talk about. Let us understand that statistically researchers won't encourage regression analysis on weighted data until and unless it is not in a mannered linear form. It is not in a mannered linear form or functions as linear transformation, and that simply have no significance. So, so the idea is that it is not usually suggested in regression analysis unless it is not in a linear form or functions with their linear transformation and have no significance. Okay. So, then only weight is going to be assigned, otherwise it is ineffective. Some researchers are also hesitant to use weights because of general theoretical and methodological difficulties. That is in fact true, and I was just talking about. So, the two references we have highlighted at this moment, there are many other suggestions as well, like general consensus in the literature that weights should be used for descriptive statistics, and less consensus on whether weights on whether weights should be routinely used in multivariate models such as regression also suggested. So, there are less consensus in this aspect as well. Okay. So, now let us understand further details of these all those things. In some situation it is necessary to take an appropriate weights. However, different types of weights are useful for different purposes. So, we are going to clarify in those details. There are different types of weights. Broadly we are indicating here as 5: design weights, non-response weighting, then post-stratification weighting, population size weighting, and combined weighting. Okay. So, we will address one by one. When complex sampling procedures incorporating several approaches such as stratification, group sampling, etc., are executed in several phases, design weights are estimated. It is basically if you have a multi-stage sampling format, your design weights are most appropriate. So, design weights are established to mutually modify individual units' likelihood of being sampled in different structure and in different layer. So, it is sampled which are generally not equal. So, just try to understand in simple term that these are applied in multi-stage sampling procedure, in complex sampling procedure, and since they have different likelihood of being sampled in different layers. Okay. Now, the design weight in a probability sample correspond to the reciprocal value of the probability of being included into the sample. So, the reciprocal value of their probabilities is going to be used as the sample in that particular category. So, usually in the reciprocal in a reverse ratio. Okay. Like if their probability of carrying to that particular variable is of let it be 1/3. So, if it is 1/3, so but the weight it is going to assign is as 3/1. Okay. So, it is in a reciprocal manner. So, that is all about design weight, and some examples also we have cited here, like if you wish to adjust the probabilities of being sampled for all the respondents, it is required. While individuals are the sampling units, households are sampled in the first stage, and therefore, respondents' probabilities of being selected depend on the level of household members. Okay? Depends on the number of household members. To solve these differences in sampling probabilities, we have to compute design weights. So, design weights we will also discuss. The next type of weight is of non-response weight. We are usually unable to obtain responses from some of the intended respondents we sampled during the implementation of this survey due to some maybe respondent refusal, maybe the investigator or the enumerator may not be able to contact the right persons for the response, or other administrative reasons. There might be many reasons by which responses are not recorded correctly. Okay. So, response rates differ between various population groups, and those inequalities can be compensated by weighting. If those are not there, some weighting techniques will all actually compensate these non-responses as well. Okay. So, that is why it is going to represent more population as well. Another approach is a post-stratification weight, that is the distribution of some variables in your sample population such as sex, age and education may differ from the distribution in actual population. Like for example, your sample is of 58% men and population is of 48% of but in the sample you have got 58% of men and the population it is actually of 48%. Okay. In the post stratification weighting is basically it is done in order to achieve a distribution equal with that of such known characteristics of the population, like this proportion which you said, that might be almost resembling with your sample estimation, okay, sample percentages. So, like in the post stratification some of the ratios are going to be different. So, that could be also compensated as well. All right. Next one is called the population size weight. What do you mean by population size weight? It is by the ratio of the population size. So, population size weights are the same for all persons, it is entirely same for all the individuals within a country, but differ across countries. Okay. Like in a particular case study, it is cited like these weights correct for the fact that most countries taking part in the European Social Survey (ESS) have different population sizes, but similar they have different in the European population European social survey they have different population sizes, but with their similar sample sizes. Okay, but sample sizes are similar whereas the population sizes are different. Without this weight, any figures combining data from two or more countries might be biased or over representing smaller countries at the expense of the larger countries. So, so the smaller countries should get a reciprocal weight, okay, because of the fact that the population size differ and there must be respective weights. Last one we are discussing about combined weight. The data file may include several different types of weights for different purposes. Okay. Subsequently, they are combined into a final and a combined weight is taken. Okay. Combined weight is followed. So, we will be discussing some of those in our explanation and how different databases are in fact utilizing these weights or deriving coming up with these specific weights. As per the DHS data set, we have listed out those weight variables. Sample weights included in each DHS record file. Okay, so, DHS file and DHS record file are different. Record they have actually processed it and they have included with their labeling, with their refined form of data, and also they have recoded the variables. Now, you can also get these information through this link we have given. You simply click on this, you will be redirected to the respective page for details. Now, the weights in this DHS example data set, we have like household weight, that is written as in the HR file, household record file, and the weight variable in that data set is HB005. Okay. Household members, so person record, basically since they are members, person record file, it is of HB005. Similarly, women and child. Okay. So they carry with individual record. Okay. So then birth record, there are different way of clarifying it. So the weight variable and its name is listed accordingly. So interestingly, if anybody is working on domestic violence, they are supposed to take the domestic violence record weight, and HIV test results are also there. Main file is there. For main file, record is different. So if you are simply taking an individual record, that is B005, and just randomly considering this weight over here and interchangeably, this will be giving you error. Okay. Your data is not going to be represented at all. Okay. So after explaining all those things, we will also help you to guide you the right directions for interpreting the weight and carrying in your own analysis. In DHS data sample set, weights are calculated to 6 decimals, but are presented in standard record files without the decimal points. Okay. So you are supposed to take in the decimal point, like the MB weight, which main file, I think, yes, main record file MB weight. So it gives a weight value of 365100. Okay. So you have to divide it by 10 lakhs. All right. So 10 lakh, if you divide, that will be your exact weight value, weight variable and its value, and that will be carrying. That variable, if it is given like MB005, you have to divide it by what? You have to run a record or generate a a variable with a division of 10,000. Oh, sorry, 10 lakhs. Okay. So that you will be getting the right weight value, and rest you can simply use your refined or newly generated weight variable. Okay. So now onwards, we are going to guide you on how you guys can go for understanding the weights and apply in your own research, okay, directly into your research. We will surely go through a sample data set, and those sample data set would also be provided to you along with this PPT lecture. Okay. So the steps are mentioned here. You please follow it very carefully. Like first we will create the weight variable. That is the first step, and we are using the DHS data. Okay, that is NFHS. The sample data is taken from NFHS 4. Okay, and the weight the data. I mean, second step is to weight the data or apply the weight. After creating the weight variable, which you on the first step, you have to include this variable while tabulations. Okay. Here we will demonstrate the tabulation of percentages of women living in urban or rural resident. So this is what the particular hypothesis we are going to find out, not going to exactly test, just to estimate the percentages of women living in rural or urban residents. What are their percentages? The data set, example data set with this name is here. We are going to open it soon. We will use the individual record file because our unit of analysis is women. I have already guided you. This individual record file is here. This is IR file. Women for children birth file is important. Okay. Individual record file should be opened, not any other file. These are available in the NFHS data, and I think we have already guided you about those different data sets on its respective page, where you guys can able to download, and once you have downloaded and how you should go for it. Now onwards, we are giving you all hands-on experiences about these techniques to go for the weights. Okay. Now, let us go for it. A variable for urban and or a rural resident in this DHS file, in this individual record file, which is available with the name V 025 for rural and urban with the categorical variable. Now, we will use the command look for, like if you do not able to tap it the exact variable, if you are confused enough, you can simply type it, you will look for, search on the command page, you will get it. Okay. Then the next step is to go for weight for the tabulation. Weight variable we have already mentioned that it is V005 for weight. I think I have already just shown to you. This is V005. Weight for that particular variable or for or data set. So, then we have to divide it by 10 lakhs, that will be generating the right weight for us. All right. So, to generate the weight, we have to use the command at generate or simply insert a gen command to create a new variable. So, we will be using Stata. I think I suggested you to get ready with Stata in the last lecture, in the last even week as well. I told you we are soon going to start with the operation in with the help of Stata. One lecture will be also guiding you about starting with SPSS, but not with all applications, or mostly we will be operating through Stata. So, the steps you have to do it very carefully is that in the command window you have to type. I will show you the command window. I have already shown that to you as well. Generate gn, then the variable name should be written with the expression equal to. After the equal, you have to give the expression, like in the example gn. Then the variable name we have created as weight, the new, that is basically the new weight, not the weight it has provided, that is weight WGT is equal to the weight variable divided by 10 lakhs. This is what we have done it in this example data set. We are going to do it now. After creating new variable, that is WGT, let us use this variable in our work. So, applying the weight, we can do that like this. We will then compare how to apply the weight. Creating weight variable does not automatically apply to the tabulation, we have to apply it carefully. Okay. So, with the command iw or iweight is equal to weight variable, okay, that variable has to be defined, then we can understand the tabulation of it, how it looks like, how what kind of percentage it gives. In our example set, like in the data, we have the variable called rural and urban location variable, it is V025 with the weight is given as iweight is equal to WGT, which we have defined. Now, after saying all those things, you have to be very careful about this command. This is what the command I have guided. Then on the next page, I have also discuss about applying the weight for our analysis, for our results, for our percentages. So, here we have applied the weight exactly as per your data. Okay. So, here we are going to experiment as well. I think it is here. I am just coming with this. We have presented the do file screenshot for you if you are a bit confused, so we are also providing the do file to you, the simple do file. Here we will compare an unweighted and weighted frequency in the individual record file. The unweighted frequency will map it through tab V025 and weighted frequency with this new variable that is generated, and accordingly we will take the tab of this with its weight, isn't it. So, these are all. Let us go by this and do some experiment. Okay. All right. Here is the Stata in front of us. So, I am going to just experiment it. At this moment we do not have data on the screen. First of all, we are also providing you the sample data for your experimentation. So, we are now opening the data. Okay. So, we will go to the file. Here is the file, I am just opening it, it is the file. All right. So, from the file we have kept it the data.
we have already opened the data on the screen. We can just show the data once by typing br, browse command, just br on it. Okay. So, the data looks like this, the data sample data we have taken. It has variables like 4275 variables. Here I am just highlighting 4275 and observation is 8348. So, this is not the exact data of NFHS. We have taken samples, sample data for our analysis. To make the file little shorter, we have made a sample data. Now, we are going to show it step by step to go for weight. Okay. So, first we are doing this, yes, generate a weight here. Here on the left hand side we have already whatever we have said, yes, that one only, yes, here it is. Okay. So, weight variable is now generated. Then we will understand with the tab value, which I have already guided you. So, the tab with this weight variable, the variable no, I think let me just show you the do file once, do file. So, here is the do file, that the screenshot of this one has already been shown to you. The tab tab of the on weighted variable, that is of 0 to 5. Now, weight we have scaled down to its decimal point. The weight variable is V005, okay, divided by 10 lakhs. Then we have taken on the third row, it is the tabulation with the weight variable, okay, or with weight. Then we have actually tried to compare. Okay. So, let us just close this, and now we can go for comparison. Let me just go back to the PPT. So, this is what is your weight, how you can operate. We have shown you a data file. That data file will also share with you all, okay. And do file screenshot also we have given, and you may also copy it on your own screen for further experiment. Now, we are comparing the results in Stata. Okay. So, like tab of the unweighted and the tab with weighted. This is with weight and this is without weight. Okay. Now, before weight, you can easily see that your urban percentage out of the total is of 41% as compared to rural. So, where after weight, the you can see that there is some adjustment, urban percentage increases and then rural is reduced. So, it gives certain weightage to the population where its size has been reduced due to sampling procedure. Okay. So, this is one of the interesting aspect we have shown to you. Like you can also follow these these aspects from DHS example report. Okay. So, like the total weighted and unweighted numbers will always be same, because the weights have been normalized as well. Okay. So, we will also discuss about the normalization technique on the next lecture. I weight can be used for frequencies and tables where you do not need significance testing for confidence interval. Especially without significance testing, I weight can be easily taken and should be taken, in fact, to represent your data carefully. So, here the data which we have shown to you with the eligible women from 15 to 49 as provided in the data set. The total women weighted number is 8348 and the unweighted number is all of this, but now weighted number actually after weight it is getting different. Okay. So, it is getting certain adjustment to the data. This is what has proved. Similarly, in other categories you can also compare and then find it out. Like using I weight, Stata assumes that the data comes from a simple random sampling. So, that is one of the interesting aspect when you are using I weight with the assumption that data is followed with a simple random sampling. That is one of the interesting aspect. You should take a note of it. Therefore, it underestimates the standard errors. Okay. So, when simple random sampling is taken, so there are high chances of of underestimation, because you if it is simple random sampling, your sample size should not be very less. Okay. But since you have followed a sampling procedure and you have taken a sample, it has to be lesser. So, therefore, it underestimates the total population size. It is important to not only adjust for weighting, but also take sample design into consideration. When we need sample design as well, now it is not just simple random sampling, a simple format has been obtained throughout, rather there are lots of design is made, lots of stratification made, lots of complex sampling procedure made. When we need significance testing in our analysis, we have to tell Stata to take sample design. Okay, that is important to note. Sample design into consideration while calculating standard errors. So, standard errors might be high if you do not consider the sample design weight. If you simply go by I weight, it might might not correctly reflect your result. It might give you underestimation. So, since most of the databases, larger databases come with complex design, sample design, it has to be set data with sample design command. To set Stata to say Stata that my data is of follow sample design, we have to go for this command. Okay, sample design weight, the sample design weight which already discussed. So, Stata command which will be employed here is SBI set within bracket PW, that is you might have heard IW weight and PW weight. This is actually important. Okay. So, PW weight is actually important. This is your weight variable and PW is your in fact is your command. Okay. Then followed with primary sampling unit has to be specified, and the strata exactly should also be specified. We will also show you with our experiment, where PW is your P weight, that is also called probability weight. It also gives probability assignment. Okay. SBI sample command needs information such as PSU, like primary sampling unit, which are the primary sampling unit in your data, whether it is HB021 or B021, we are going to just clarify. Strata like whether SB023 or B023 in case of some countries, it is SB022 or V022 as per the DHS data. So, weight also, the weight variable is also required. So, now here SBI command, SBY set command, we are supposed to set our command to the Stata. Again we will use our sample data set. Okay. And that is individual record data set that we have just shown to you for women, okay, eligible women. The Stata command that we are going to apply is generate weight is equal to it has to be scaled down to decimals. So, we are again dividing it by 10 lakhs. All right. So, the SBI set SBY set command has to be applied like this. P weight and the weight variable we have already generated in our data. Now, the primary sampling unit is also defined with the variable 0 to 1, and it is given in the report of that data set. You need not confuse what is called primary sampling unit, it is clearly defined in the report, and the strata variable has to be defined as per the instructions. Okay. So, here is the strata output. We are once you give this command, we will get with these things on our screen. Okay. So, we are also going to experiment just now in front of you in the screen. Okay. Like this, I am just going to do this. So, if you open it, we can do that experiment as well. So, weight variable we have already defined, isn't it? So, here is the command. The command is in front of us. SBI set PW weight, and the PSU is defined, and its Stata variable is given. Now, Stata has given you this output. Now, we are simply going to get the result, all right, in front of you. Yes. So, now you can find out the proportions of rural and urban. So, this gives in proportion, but you have in your interpretation it has to be in percentages. It should be out of, it should be instead of 0.45, it should be 45%, 45.11 for the urban, and for rural it should be 54%, 54.89. So, now you can understand that your design weight is coming out with different proportion, whereas in the earlier case it was of different percentage. So, I am just coming to our PPT once again, then we will clarify further details. Rest I think you will understand. Then we have also given you the command to compare the result after the weight. So, basically once you have taken the design weight SBI command, your tabulation should be start with SBI instead of just tab. Just tab is not going to give you the result. So, I weight should be used for simple weighted frequencies, that is especially for simple random sampling technique whenever is applied. So, P weight is applied when you have a design weight, but subject to you already given a command for SBI to the SBY to the Stata. So, especially it helps in giving you a right standard error, its p values, confidence interval, etc. Last couple of guidance in another 2-3 minutes I am going to just clarify, and rest of the details we will experiment in other slides as well. Stata command for weight in NSS data, National Sample Survey data. I am just referring to the NSS 7/5. I am just giving you one document in front of your screen here. I have already shown to you about this earlier, like the readme file of 7/5 round is here. This suggests that you have number of records, and especially regarding weight it has guided very clearly which kind of weight should be defined. Usually we go by the multiplier as the variable for the weight, but final weight should not be just multiplier, it has to be with your certain steps, like it has given the final weight as either MLT by 100 if your subsample is equal to its sample combined, subsample is with your subsample combined weight. Okay. So, then you have to divide it by 200, then you consider that weight if it is not equal to. All right. So, we are just doing it for your guidance, for your understanding. So, these things we will also discuss in other slides as well, other lecture as well. I am not emphasizing much here, this is what I have simply said, like you have to generate a weight equal to dot, that dot has to be replaced with this command. Okay. So, that likewise we generate a new variable. So, similarly we are generating a new variable called weight with a dot, and that dot is filled with this information. So, MLT variable is already available in NSS. I am not experimenting this at this moment, but I will just guide you. MLT by 200 if NSC is not equal to, this is the sign we use it in Stata, not equal to in the keyboard is not available. So, Stata gives this information explanation mark equal to NSC. So, if they are equal, then you have to put double equal to, and it will generate a right weight. Okay. Now, review in the review of commands we have already generated and discussed today, like we have discussed about generating weight,
so expression has to be given. So, by the simple random sampling technique in general studies, we have to go by tabulate with variable that is I weight variable. Then in the case of design weight, we are supposed to give with SBI set command. Then we can tabulate that variable and we will get the right result for our study. I think these are all guidance so far, and we will be repeatedly using in our coming lectures, and it will be consistently helping you to understand the right analysis of the data. I think these are fine at this moment. We have probably exceeded a bit of our time, so we will compensate in the next class. With this, I think I am closing this session here. Thank you.